welcome to our session. My name is Juergen Heymann.
My name is Oleg Kutyrin.
And we want to talk to you today about applying DDD for a large-scale integration project at SAP. And so we're going to kind of trade off between slides, walking back and forth. So we're doing this together. So just to give you a big picture, high level, what's the big picture story? So SAP is a big company. We have some big applications already historically, but then there were some very big acquisitions. I'll talk about them later. And so you get a portfolio of some things that haven't grown together. And we run business processes across them. And you can imagine, of course, the data models that are visible there at the APIs do not match up. And that is actually a problem, because then for the customers that integrate them or say, I want to license this, this, and this, they have specialized, and every customer has to work on some integration stuff, at least in part. And especially bad is the issue of configuration and master data. So you want that the same across all systems, so you have to figure, well, we have to exchange it somehow, make sure the product is the same in every system when you try to sell it or when you manufacture it and so forth. Or at least you're talking about the same thing. And so what we're doing, and this is what we're going to talk about, is how to basically make a data model on top somehow about those systems, and that way to integrate them, and how we apply DDD to that problem. That's really what this is about. And so why we're talking about it is because we're looking for some patterns, actually even last year, and we want to just share what we found and some initial things that we found that may be useful to others. Before I can go on, I have to, the usual disclaimer, everything we say now we believe, but it may be wrong, and everything may be subject to change, no commitments, no warranties, the kit drain, right? So since we're through, we can continue. So SAP, big company, 100,000 employees. I think we have now 25,000 plus developers all over the world, and the numbers you can look at, but what's more interesting is actually the other side of the products there, because those little circles are huge projects. So for instance, the first one, network spend management, there's 2 trillion trade volume per year, purchasing procurement solution. People, engagement, 200 million customers, digital core, 300 million lines of code. And this is about the scale of stuff, of the individual components that we're looking at. So of course you can't look into that in this kind of scale, but this is the size of the system, so just you have an idea about that. And oh, this is already your slide now.
Done first, okay. Good. So what does it all have to do with DDD, right? So actually, Juergen and I tried to introduce DDD at SAP since quite some time, because we both believe it's a good idea, right? It brings in the right separation of concerns and so on and so on. So actually, my journey at DDD started even earlier. So I was at the central architecture group of SAP Cloud Platform, and we tried to, around 2014, we tried to answer the question, what would it mean for business application to implement microservices, right? And one of the most challenging questions in microservices is how to get the right cut. And so I came to bound context and started thinking about that. So I created actually a prototype of mid-size business application built according to the DDD principles. And then we started talking to Juergen. I found out, okay, Juergen is also on that. We worked on some project years ago, actually, together. So, then we thought, okay, it would be a good idea actually to introduce DDD at SAP. So what we started doing is we started going into the development teams, finding out what the problems are, how we can help, and at the end we created kind of standard workshop for development teams, more or less according to the patterns described by Alberto. So event storming, identifying bounded context, so mostly addressing the componentization issues, right? So, and it was sort of very fun and very good activity. But last year we both changed to CTO office as an organizational unit, and then we immediately got a task to be involved into the large integration project, and we thought, okay, DDD is a good idea to apply also there. So what this all is about? some of you may know, some not, how actually implementation of business processes on SAP companies normally works, right? You deploy the components, right, and then you try to find out what integrations you should implement to make this business process be orchestrated, be working. The problem is SAP has quite a few acquisitions that were made in the last years, so which means several things. So the first one, you have overlapping business functionalities. If you're acquiring something, most probably you also have it somewhere else in your company, which means also you, if as a customer you are trying to implement integrations, you first have to find out what part of functionality should be implemented where. That's sort of already a problem, right? Another problem is normally the approach now is to implement the point-to-point integrations, right? Which means you have different bounded contexts, they have own understanding of business semantics of business entities. You need to map them to make the replication to another one that takes care about the next steps in the business process. And actually also finding that out is a difficult task. So in other words, integration or implementation of business processes on existing SAP components is a kind of challenging task. There are, of course, integration best practices in the meanwhile. Still, it's considered very expensive. So, but if we just rethink it a bit, so what we have as an input? As an input, you normally have a business process, right? And there are quite a few standard business processes that are kind of universal, like recruit to retire, that covers the life cycle of your employee from the first interview through recruitment down to retirement, you know, paying the salary and all that stuff. Lead to cash, right? That is more or less CRM-centric process that tells you, okay, you have a prospect, so potential customer, it turns to a customer someday. Then you create a lead, maybe you run some marketing campaign, and so on and so on. At the end, the goal is to sell to that customer something. So at the end, you get things like sales quote, sales order, and so on. You ship to the customer pays, everything's good. Source to pay is a classical procurement. So you have your supplier, you collect purchase requisitions in your company, you set the purchase order to the supplier, and so on, right? These are more or less standard processes, right? And it's kind of open set, so there are also others, trail to reimburse and so on. Out of the processes, you already can say what key entities are there, right? So, like, for example, it can be some sales domain, domain-specific entities like customer, sales quote, sales order, or procurement domain-specific things like supplier, purchase order, purchase requisition. So we call it one domain model, but don't be confused, it's not like one domain, it's really kind of brackets, right? More organizational brackets than really content brackets. So then as the next step, what you are going to do, you are going to implement these entities in the existing solutions, right? So what you have is normally ERP, you have CRM, you have HR solutions somewhere, right? And again, maybe much more time. So what you do in the new world is actually you implement some message bus based integrations, and you assume that the existing solutions already talk this speak this one domain model language, right? Which is kind of common language, kind of and for that, of course, if they should talk to each other using this language, they need to implement the ACLs. They should transform their own implementation. So one important boundary conditions, we are not required to re-implement the existing solutions. They should just implement the ACLs. So if we think it's just a classical bubble context problem or solution problem. Actually, the same thing should happen for the API exposure. And that's the part where I'm now active. So Juergen is rather this one domain model. I'm rather this API for external consumption. The problem is, if you look at the APIs of different solutions, then you realize that creating an application on top of that is very difficult, right? Because then you again have hundreds of different representations or different understandings of semantically similar concepts, and you have to realize what comes from where and how to deal with that, and then you get sales order from one API. You have to somehow again transform it to set probably some things that are relevant for another API, and so on, right? So what we're trying to do is we're trying to say, okay, this API for external consumption also speaks this ODM language, and for that you again need some ACLs. So that's more or less the big picture. That sets our boundaries, and that's already the slide.
Okay. Yeah, and of course, alignment is not the first thing that anybody tried this at SAP, and it happens within systems already. So especially in bigger solutions that already again consist of bigger separate components, this is done. And one example here, I just wanted to give you an idea, is so in the ISOA times, around our S4 system, there was a layer of APIs being built that looked consistent. So again, also not rewriting the code inside. But just to give an idea, just the type catalog was 1,600 pages PDF. This is the biggest PDF I've ever seen, and it really is just, I think the content starts on page 380 or something, because the rest is up there is index and the names that you see here. And so you can imagine it's a big system, but it's interesting what they did is that there was a rule for how to define names and types that you can see from a name like this here, you know exactly what's inside. So for instance, one thing that we also do is when it says code in the end, it's a code list, and it means that there's a list of codes centrally managed that has, for instance, language or country, EN is how, no, EN is not a country. Country US is United States, for instance, and there's language codes, country codes, and all this stuff. And this is the stuff that you configure, for instance, in configuration of a system. So anyway, there was this huge effort to unify this and make a model about this. And this was actually very scary for us, because we thought, oh my gosh, they did this for 5 years with 100 people in a core team. What are we going to do with our 10 people, right? And so I just want to mention this, and also to validate, this was a great thing. These guys were probably smarter than we are, because they had a big setup of governance and great rules and meta model and everything. And so we want to take some of that over into the new world. So basically what we're doing is, what's visible on the outside of the system, whatever we need, is what we try to elevate into the next level of the model. So what's already there in the system, and others have other APIs that of course expose models. We only look at what's visible outside. And so how does DDD make a difference? And like I said, you know, people, when we started this, they said, oh, you're going to fail. There's no way this is going to work. You know, we tried this, and the developers didn't have time and all that, and they didn't want to do it. So why can there be hope? Well, let's look at the big picture again on a little different level than before. So we have the systems here, and some systems implement many domains, bounded context, if you will. So like the ERP has 25, 30 real bounded contexts in it, like finance, production planning, you know, totally separate, very huge components in them, and other systems of course have that as well. What we're doing is that say, okay, you have a big domain here, there's a part of that that you expose into the shared space here, what we call the ODM, the one domain model, where all the new stuff meets, and this is the things that are exchanged, and this is only what is needed, and we'll come to that. So, and this is one of the reasons why we can have hope, is that the scope that we're dealing with is much smaller. So it's actually surprising now that we're 5-6 months in deep integration discussions that there's in total 50,000, depending on how you count, to 100,000 entities together in these systems. I mean, semantic entities that people develop somehow that end up in database tables. But up here, we're talking about 100 to 500, depending on, you know, estimates or so, objects that we need to put stuff together. So it's a much better manageable scope. So we have number one, much less scope, and then the other thing is, this is where DDD comes into play, which we're hammering down on people, that we want domain separation at all costs. So if you look, the other thing that I showed before on the previous slide, the whole system that was, you know, with those huge type catalog, the whole system was aligned So if you find a type anywhere in the system with a certain name, you can go to the catalog and find out what it is. Which means that the alignment scope was 300 million lines of code. You can imagine that this is really hard. And so even though the code was not changed, it's meta information, but still to figure out the semantics and nail this down, this is a huge effort. So one thing we're doing is, and this is kind of an upfront training effort for people getting involved, explain the whole business of domains, keep them separate. And, you know, the same name, it doesn't have to be the same thing, it doesn't have to be the same class. This customer is different than that customer, that kind of thing. So this is actually a main element, and you'll see it in some patterns later on. And then what we did is we've thought about some hard rules we want to enforce to make things consistent here, but otherwise we try to do much less governance. So one level down, what does it look like? So let's say you have these applications again, and there's a business object that is owned by, and it's a simplification because it's also even configurable, but let's say a customer object is owned by a certain application that has the master, right? So what they do is they have a big object, 500 fields, they expose maybe 50, that through an ACL goes to the shared one data model, and that gets replicated in here to other systems via master data service. And so this, basically you can see the data flow here. This guy says, oh, I need 5 attributes, I'll throw the rest away, they need 3 others, and so forth. And so some consume this, and then even, for instance, here you see, the customer and loyalty management, it's of course the same customer we're talking about. So you want to be able to map them, and that's why you have this data. But you have like what they ever bought, loyalty points. Of course, you don't want to have that in the master. So we keep those domains separate, and in fact, this is a separate system. So this means if they ever want to expose their data, they can do it, but it will be a different object. And this is what we do by namespace. So this is the core customer, loyalty management customer. This is how that works. And what's interesting too, we have, of course, existing APIs at those systems. So even though they're not consistent between them, there's lots of code that interfaces with those APIs. And if we start a new world up here and say, you know, welcome to the new world, but you can't connect to the old, nobody will come, right? So we have to make the transition both ways easy, which brings up the topic of ID mapping and so forth that will come at the very end. So what does stuff look like? To just give you a quick idea, we are defining real data models. So it's not just like RDF metadata only, what is a customer, it's somehow spread in the code, but there is a model that defines fields and relationships and annotations that have, you know, documentation. From this we generate APIs, for instance. And this is, for instance, it's a root, so aggregate root, you may be familiar with. So we have a bunch of entities, we say aggregate root, that's this entity, and then everything linked by composition is the aggregate. So this way we can find out what is the an aggregate scope. This is the unit of replication and so forth. And it has, you know, other downstream implications. So some design principles and goals we thought about up front. For one is we wanted to have, like I said, one common data model representation like that, where we add a few annotations, but it should be data model focused only. And then from that we generate more representations. And we strongly want to support independent evolution of domains. So one big thing in a monolith you often have, somebody comes and says, oh, give me a field, I need to store something for the customer, which is there. And then you have to wait 3 months, you get the field, and then you move on. So this whole coupling we of course cannot have. And we want to support fast iteration. And that had some implications, which we'll see later on in the patterns that we present. And also we assume a distributed system, which means that at least the domains, but actually in reality every aggregate in principle could come, if you do subsequent calls, could come from a different system. Those also that has implications. And that leads to discussions, of course, with people who are more, you know, used to monolithic world. And then, of course, consistency only within. So this is, again, composition, aggregate, that's where consistency is, and then eventual consistency between them. So this is kind of like what we told the people doing the modeling, doing the alignment from the applications, what the semantics of that model is.
So, and what we are gonna present today. So basically, we identified a set of heuristics that may be useful also for others. Just a disclaimer: it's still in work. Everything is, whatever is under discussion. What we present is now more or less stable, we believe. So there are also ongoing discussions and open points which we will list at the end. So. Just to be precise on that, so it's not that we are the two most clever guys at SAP that kind of created this heuristics. It's a result of work of the entire DMA core team. So what we try to do, we try to separate the heuristics into two groups: organizational and modeling. Although, as you will see, sometimes it's not black and white. So some have also flavors of another group. And modeling heuristics is also, as you will see, on very different levels. So some are really design heuristics, some are really modeling heuristics in terms of concrete entities or concrete entity patterns. So how we came to that is normally every heuristic we identified was a kind of solution for a particular problem we had in the discussion. So that's why I think it's kind of bulletproof. Not really bulletproof, but at least it's proven that there is a problem for that. So, and the first heuristic that we have is it's purely organizational. So when we started, we thought about different team setups, different organizational setups, and even tried out a couple of options. What worked for us at the end is the following setup. So you have a core team that is taking care about defining the guidelines for alignment. The alignment itself should happen on a per domain basis in independent groups. Only this way we can scale. Important point is that the core teams should not only issue the guidelines and send to the alignment teams, but also it should take care about the technical modeling. So the business alignment is one thing, but you also have to describe the results in the language that Juergen just showed. And this is the task of core team, because only this way they can check the constraints they set in the guidelines. So the heuristic here is more or less, okay, set up central team that defines and enforces modeling guidelines. The alignment itself, and that's the most challenging task, happens independently. So, interesting problem that we actually had in the beginning. Nobody cares about DDD, right? If you are coming to a developer, to a business expert that should be involved, if they do not want to learn it themselves, they tell you, okay, go away, I have other problems, so I don't want to hear about bounded contexts or whatever, customer supplier pattern, and so on. So, what we did at the end, we said, okay, guys, we are not requiring you to learn DDD, to read books, and so on and so on. We are creating the guidelines that are mostly concrete and mostly address the problems that you have. So in this sense, this core team I showed on the previous slide is a kind of ACL between the DDD bounded context and the company bounded context, if you want. So our recommendation is, in such setups, make DDD just invisible and define really very concretely what should be done in the current environment. A very important design topic is separation between domain model and representation. So what I showed before is, so you have a business process as an input, you somehow distill out the ODM out of that, and if you see, I'm showing it now not as a round shape, but as a hexagonal shape, which is for purpose, because in fact it's our reflection on hexagonal architecture, right? So you have your really core thing, and you have different adapters, so different representations of that thing. So you have to represent this one domain model as REST. You have to represent it as GraphQL. If you expose GraphQL APIs, you have to generate JSON payloads for messaging, right? The applications themselves may decide to use that to generate persistence in their world. But important is the concepts from this representation should not leak into the ODM itself, right? So we had a discussion, okay, let's model URLs as references in ODM. Okay, fine. It makes sense for REST completely, but it makes zero sense for GraphQL. It makes even less sense for messaging because messaging should embed things, right? It cannot show other things in a different log record, right? So that's why the recommendation here is domain model only takes care about business semantics, not more, not less. So the representations should take care about rendering and whatever representation of ODM in a particular world. So also rather organizational question. Surprisingly, our project doesn't have endless capacity, right? So, and the question is how to prioritize the work in a right way. So, as Juergen, I think, shortly mentioned already, the data may be of different types or different archetypes, if you want to be fancy. So, and it already gives us a hint what should be taken first, what last, right? So, if we look at a very simple example, so you have a sales order, right? Sales order is basically a kind of description what is bought by some customer, what products, and at the end what should be fulfilled that is shipped to that customer, right? Sales order itself, it has a reference to the customer. It has to. And the customer itself has something like headquarter address. And headquarter address references a country, so which means we have to maintain the list of possible countries somewhere in the system, right? That's what Juergen called the code list, right? So that is a code list. Sales order itself also has a reference to country because it has a shipment address, which may differ from the customer address and so on. So it also references country. If you look at the nature of data, you see that it's really different. Sales order is transactional data. It has a short life cycle, so basically it's created in the system. You do something, you approve that, you fulfill the sales order by shipping the product, and then you can delete it or you can archive it, whatever, right? And it has full business semantic actions and so on. Customer is already different. Customer is so-called master data. It has a different life cycle, so normally it's created using some specialized processes called master data governance processes. It's not that everyone can come and create a customer, right? It has less business logic. Normally it's really CRUD entities. Important thing is it is extensively referenced in transactional data. Transactional data itself rarely referenced by something else. Master data it's very often. Country is again a different data type. It's reference data, right? So it's really like ISO 31661 list of countries, and it changes very rarely, basically, right? But it is even more referenceable from master data or transactional data, which already gives us a hint. If we focus on master data and reference data and address transactional data when later, then it will give us already a bigger benefit in the alignment process. So the recommendation here is, okay, start with reference and master data and somehow address transactional data a bit later. Juergen.
So now we're coming to first modeling patterns. And this is actually already an interesting one because this has caused a lot of interesting discussion, or I wouldn't say fights, but with the existing worlds, right? So if you're in a monolith world, typically you find those God objects that know everything about the customer, right? So, and everything it collects there in a bunch of tables that are very tightly linked together. And so you maybe find some core data, but also if you know, just as an example, the product, right? You have some core product data, but there's a sales, there's pricing, there's production, how do you build this thing, supplier, all these things. So somehow very close to the product. And we said we wanted to separate the domains. So how do we do this? Well, we said, okay, as a first thing, as a paradigm to say, core object and extension aspects, we call them, they live in different domains. What does that mean? So we said, okay, if there's a product here that is used in different domains, okay, the red part is really what's common, and this is how we try to first visualize it. And then green is, the whole domain of that, whatever this is. So this may be sales, this is commerce, this is, e-commerce selling, and this is who knows what, maybe production, I don't know. And so this is the core product. And the yellow stuff is interesting because what you need often is that one domain, like the sales domain, provides data for commerce so that this product can be sold. So, for instance, does a product have a price? Yes or no? In the real world, yes, but does it have a price in the system with the product? No. Because the product can be sold in many regions. Is it a part of a campaign? Is it part of a package? There's so many indirections before you come to money that you can never store a price with a product, right? So the price is here, and if commerce wants to sell something, they need to agree on sales-related data about sales regions, responsibilities, all kinds of stuff. So you don't want to need to talk to the product about this. So this was like, okay, this drives home the basic idea, and you need to then say, even if this is the case right now, the product master knows everything, we're going to split it up. So if it shows up in ODM, it will be different objects. Even though right now you know everything, dear product manager, master, we'll have to split up some things. And then, of course, you need to know what stays together and what is split up into different domains. Then the question is, okay, who owns the entity model and even who writes it? Well, actually, no, who writes it is already the answer. So who has most influence on what the model should look like in a scenario up there? Well, the one who writes it has the data, and the consumers say what they need. So if you look at an alignment scenario, the yellow is what C needs, and A provides maybe, and red, so they argue, okay, this has to be on the core, and this is only between the two of you, so this doesn't go in the core. But it's an important part to consider for always. Also, where does the domain live? Who writes the data? So, for instance, the sales data used to be, the sales parameters used to be written in the product master. But who writes the sales data? Well, the sales area guys, they say, the new sales region, blah, blah, blah. So the sales domain writes the data, and therefore it belongs there. So that's the heuristic there. And so in reality, it looks more like this. If you look from the object part of things, so the entity part of things. So this is the core object. There is some more data that is not exposed. So we're not showing this. We don't have this blue separation now, but just the model core object. And these are the extension aspects. This is from sales. This is from somewhere else. They point to the product, but they don't copy to it. So live in different domains. And so these instances are also separate. And these are associations. So even though you may say, well, logically, the product, if it's deleted, I also have to delete those aspects. Yeah, but you can't, because this is not a composition. It's a distributed system. So you have to deal with that somehow in another way. But anyway, the heuristic there is, so you clearly try to figure out what belongs to the core entity, what is really inherently there, as the same cardinality, everything, and what is actually a different aspect that lives and comes from a different domain. Then the thing we ran into was, this other picture where you saw, okay, I have a customer and I have a loyalty management customer. How do you link them if you want to say it's the same real customer? And this is in a fictitious example, as we see later, but this happens. And so we thought, okay, there are three options that we can think of. One is we can say, we actually technically use the same ID here when we expose it into the ODM layer. Because we say, well, what makes a reference unique is anyway the type plus an ID. So we can say, okay, when these three are the same, then we could say it's actually the same real customer. Now, alternative would be to say I have a group ID or something that says somehow an ID that links the three. So the reference itself, so the technical ID, to point to the instance may be different, but there is maybe a separate ID that you implement to say this to express the sameness, same real entity kind of thing. And the third option is, of course, if you have a master, like the customer is created first up there, then you can just point to them. So then the shared ID actually becomes this ID. But there's some different choices. It's a surprisingly simple problem with nasty implications. So we came up with, well, this looks like a nice solution, but probably this is the second best. So actually we're not really sure yet what to do finally for the whole thing, but this is one current discussion. So this is the current thinking. And then this is also a very interesting one, because this one was also highly discussed and still is. How do you implement roles, which is a variant of what you saw before? So many models, if you look in business applications, they have the concept of a business partner, which can be can be a person, organization, or group. And they have roles like customer, supplier, vendor, and so forth. And so in a classical system, you would end up, I have a business partner service, and these things are implemented inside. But then the supplier suddenly lives in the business partner, and it should live in the procurement domain. So what is it doing there? And we get into this other situation. So speeding up, basically what we said, okay, this must be separated. There is business value in saying what is really unique, like a person. You want to be able to identify, I already have this in the system. I don't want duplicates. This is for persons and as well for customers and everything. So you want this unique, which means this ID is used to say, I already have this guy, and they point to it. But another application of the previous extension pattern is, of course, the customer and the supplier, and there's actually lots of these, they live in their own separate domains, and they're just linked. And however that is done technically. So roles are again modeled as separate domain entities. And I'm going to just skip this, because it's just a special case, and now it's you again.
Okay, I'll try to be short. So actually, since the domains are evolving independently, you need to think about versioning, right? Because the consumer must rely on some capabilities of this domain. So, which means at the end, this one domain model, which is rather kind of loose brackets, it should contain or will contain the domains with different versions. So we actually decided to use semantic versioning for them. As you know, semantic versioning also has defines different rules for page, minor, and major versions. So we had to define what it means for the domain models. We did that more or less. That's the current more or less the current draft version of that. So our recommendation is top-level domains should be versioned separately using semantic versioning, but you should define the compatibility rules definitely. So, very interesting problem is domain localizations. So, the problem is you have some business entity which may be slightly different or much different for different countries. The very obvious example is text forms, right? Text statements are very different for different countries, right? So they may have, let's say, additional fields for particular countries, or may make some fields that are mandatory in one country optional for this one, or even disappearing for this one. So I would like to illustrate this problem and our solution with a more obvious example is postal address. So who thinks that postal address is simple? Okay, yeah, good guys. So postal address, actually, I moderated the alignment on postal address, and I came with actually very naive thought, okay, must be not very complicated. So believe me, postal address is one of the most complicated problems that I saw in my IT life, and I'm quite some time there. So the problem is that, of course, the postal systems in different countries developed independently on each other. That's why, along with very straightforward US address, you have very exotic things in Thailand address, for example. What you see there is this soy, right? Soy is a very specific to Thailand thing. It's a kind of small streets that are sort of coming to a bigger street and so on. You will never able to sort of map that to the US address, for example, right? Also, Russian address system is not very straightforward because it uses potentially 3 levels of addressing of regions, right? It has this Krai, then Oblast, and Rayon. So, and it's really very specific, right? So, and it immediately starts with questions, right? What language should you use for the model if you need to create some generalization? And you need to create some generalization, otherwise all your 100 solutions should learn all 95 different address systems, and it's not a viable solution at all, right? So for integration, you need some abstraction. So what language do you use? No-brainer, English, US, fine. But then it starts again. So you have a kind of notion of district that has different semantics in different postal systems. Sometimes it's above city, sometimes it's a region in the city, right? Okay, so our first approach was, okay, why don't we take already existing global data type catalog address definition, as Juergen pointed out, this 16,000 pages PDF document, it has address definition, which sounds quite universal. The problem was the existing solution denied to, no, not really denied, resisted to kind of accept that, because they said no, it's very ERP specific. We would do it in a different way. So it's a typical not invented here syndrome, right? And just to overcome that, I looked, maybe there is something more abstract or more, let's say, commonly accepted. And yes, so recently there was an ISO standard released for postal addressing system, and then we took that as a common basis, and the discussion started running again. So our recommendation is, instead of taking one particular localized domain, create some Esperanto. If it's already there created by some standardization body, take that. If not, okay, you have to create your own one. So, as we said, there are some ongoing discussions. ID mapping, Juergen already mentioned. So it's a typical bubble context problem. You have a new world, you have an old world, right? The data instances are already in the old world. You have to address them somehow. But you also want to harmonize on the new identification system. So you need to map somehow the new IDs to the old IDs, or maybe the IDs between the old systems somehow. So we're discussing that intensively. Another interesting problem, again due to independent evolution of domains. So basically, what happens sometimes, you have already a data instance in your legacy solution, in your legacy bounded context, but the model for that is not yet available in the one domain model. So what do you do in that case? So current way of discussing that is, okay, you create a stub object in your own domain, which it does not have a corresponding object in the domain that you are referencing, but at least you will give it an ID that already exists in your legacy bounded context. So yes, it's not harmonized in the sense you need to use sort of another API to take that, and maybe another model form, but still it's somehow addressable. So when the entity comes to the ODM using ID mapping, you can address it in IDM as well. So, Juergen.
What have we learned? Yeah. Yeah, this thing with ID mapping, is this on still? Oh yeah. It's nasty because why is it such a problem? The modeling border, because we want, this versioning thing, we want to be able to grow the model without causing incompatible changes. And if you use an ID in a payload, and now you change to a reference structure, suddenly you have a different payload, and then everybody has to adapt and so forth. So you get all these pieces where when a new object comes, the new pointers come, and then there's all these changes all over the system just to adapt for the growth. And you cause a lot of noise because of that. So that was that reason. Anyway, so what have we learned? Actually, me personally, I was a little frustrated after a while. I thought, I thought DDD, and everything, but now what did we really talk about? We only talked about data modeling the whole time with the people and the applications. Yes, with a twist of DDD, domain separation and everything, and integration. But first of all, events and commands, they're not part of the meta model. So we only talk about exchange data. This is what we're doing, and of course this trickles down to APIs, as this is the payload of APIs and messages and everything. But this is something to understand, but I think it is valid that we do this right now, and actually maybe we're adding some stuff later. And then we wondered, okay, value types, aggregates, where are they? So aggregates we saw, right, but the value types, data consistency, how is it done? Well, there is no code, so there's no code protecting consistency. What it really means, and we have to tell the applications, of course, we expect the application to write consistent data. So that's what they have to do. So there is no code on the ODM level that guarantees anything. And if you have two writers, so normally you have the single writer case, let's say, that makes it simpler, but if you have two domains that can write to the same ODM object, for instance, we have two solutions that deal with employees, they can do this. They have to have the same rules about consistency, obviously. Then what's also interesting, and you didn't see all of them, but the things that we showed is it turns out that the most difficult and interesting questions, they actually had to do with relationships between aggregates. And actually we're not so sure what to make of it yet, but it seems to be that there is really the modeling challenge, because it has more of, one attribute more or less is it's not hard to discuss. It's typically pretty easy to decide. But relationships and what's behind in the model expressiveness is much more difficult. So that's an interesting point to watch. And then we thought, okay, what now is this shared kernel? Is ODM one big shared kernel? In a way you could say yes, because everything is kind of public, but like what you saw in this egg diagram, there's actually many little shared kernels between the domains that actually integrate. So every process has the shared data, and then when they do something there, they don't need to talk to anybody else. So actually it's not one shared kernel. We have one actually with a few global types in it, but it's not 16,000, it's more like 10 or so, 20 global types. And then there's many little what's shared between them, but that's also interesting. You get this, this guy with this and this with this, and it's very scenario oriented. So as you can see, we feel we just got started, and we're still discovering more problems than solutions. But I hope we can tell you more next year what we learned in the meantime. So this is the end of our talk right now, at least.